All right, so now let's quickly go to the PSCF. All right, so PSCF is also another way of checking if our data is stationary. All right, so you see the lines are way below the blue dotted lines. So now let's go to the next condition, which is to check whether there is an arch effect. To do this, we are going to use the arch test of our time series data. So we have a control enter. We do control enter this. Now look at our result under here. Our result here, the null hypothesis is telling us that there is no arch effect. Now let's go down to the p-value. The p-value is lesser than 0.05, and this means that we are going to reject the null hypothesis and accept the alternate hypothesis, which says that there is a significance, there is an arch effect. All right, so having fulfilled all these necessities, then we can now apply an arch 1 model. To apply an arch 1 model, we are going to type in these functions here, save it under the variable name spec. So when we have typed it, so the function is ugag spec open bracket variance dot model is equal to list open bracket model is equal to standard gag. All right, the gag order is going to be 1 0 because we are talking about the arch 1 model. So here is going to be 1. If we want to include the gag information, it's going to be 1 1 model. Okay, so now having done this, we control enter. All right, so it's saved here as spec. Then we are going to fit this arch model to our data. And how do we do that? Let's save it under the variable name fit ugag fit spec. So remember, spec was the model specification we did earlier, which was this. All right, and our data is our time series data price. Okay, so we'll do control enter. All right, so it has been saved here as fit. So the next thing we are going to do is to run this. All right, so this is the information we are having. All right, so here the gag model fits. Remember from the other video, we said that the arch model from here, the arch model, the key concept is the conditional variance. So in R, what we are going to be emphasizing on is the conditional variance, and all our parameters under the conditional variance are what we're going to be looking at. So for this, when it is significant, we say that when it's significant, what did we say here? So we say mu represent the conditional mean, and when it's significant, it suggests that the conditional mean of the series is different from 0. From here, we can see the estimate, which is different from 0. Now, the autoregressive one, which is this one here, we said that the autoregressive coefficient of the ARFIMA is measures the linear dependency of the series on its part value. So if it's close to 1, it indicates strong autocorrelation with previous values, and if it's significant, it suggests the presence of autocorrelation in the data. So here we're having 0.99, so this is very close to 1, so there's showing indicating a very strong autocorrelation, and it's significant here, so it's telling us that there's autocorrelation in our data. Now we have the moving average. The moving average, if it's significant from here, in the moving average, if it's significant, it indicates that the errors in the model are correlated, suggesting the presence of a moving average component. So since this is significant, it's telling us that the error here is different. What did we say here? The error terms here are correlated. They are not different, rather they are correlated. Okay, so there is a relationship between the errors for this given data. Then the omega is the gag constant. All right, the gag constant term, and it presents the unconditional variance of the time series when no other information is available. So when it's significant, it suggests that there is inherent variance in the data, even without considering the past values. So if it is significant, so from our analysis here, it is significant, but the moving average here, okay, the moving average is also significant, so the omega is also significant. So it's telling us that there is inherent variance in our data. So for alpha here, we said that alpha represents the impact of the squared previous error term on the conditional variance, and if it's significant, it indicates that the conditional variance of the series depends on the past error terms, and higher values suggest strong volatility. So here we are having this estimates, which is not that high. So this is telling us that the volatility clustering is not very high. Okay, so, and it's significant, and when it's significant, what is it telling us? That the series depends on the squared past error terms, right? So this is how to run an H1 model. There are other informations that are here that will be needful depending on what you would want to use the information for. For example, the information on criteria, the Ike, Bayes, sheep data, and the Hannah Quinn. All these are various criteria that we would use when we are talking about which model will be best fit for our data. But for today, our concern is just the H1 model. So in our next video, we are going to be talking about how to do a GAC1 model, an EGAC model, a TGAC model, a PHI-GAC model, and so on and so forth.